All right. Good evening, my friends. Welcome to your Friday Night Live, where I am full of objectivist, taxpayer outrage. Not in rage, not in peace, outrage. Outrage. So, I'm going to rush in where angels fear to tread, and I'm going to talk to you a little bit about the massive intergalactic bullshit known as modern physics. I mean, I kinda knew it was bad, but I didn't know it was this bad. And they have the nerve to talk to religious people about faith when they can't explain literally 90% of that which exists. 90%. 90% unknown. So we're going to talk about two things, and, obviously happy to get your thoughts on this. I'm going to talk about dark energy and dark matter. Now, you may think that dark energy and dark matter describe something. You would be wrong. Dark matter and dark energy describe nothing. They are absolute fudge factors because physicists cannot explain a couple of basic facts about the universe. Two basic facts that can't be explained. Number one, the fact that galaxies hold together. When I was younger, I used to have a little mental formula that I would recite to myself if I was concerned that I was getting drunk. And the formula was, a galaxy is a mass of interconnected stars held together by a central gravitational force. I've really only been drunk about 3 times in my life. The last time was when I was 21, so almost 40 years ago. Anyway, for some reason, that was just my little mantra of, if I can recite that to myself, I'm drunk. Another reason why I really never got into drinking is because I just get physically dizzy and get the spins. That old thing, you're not drunk if you can lie on the ground without holding on. And so one of the things that physicists have to explain is how galaxies stay together. Why don't they just fly apart? There's that bulge in the middle. Well, I guess we men know all about that. But there's this bulge in the middle, the disk, and then the bulge in the middle, and they can't figure out for the life of them how galaxies stay together. They've looked for rogue planets. They've looked for black holes. They've looked for all kinds of crazy stuff. Dark matter being created with antimatter and being destroyed, releasing neutrons. They've tried everything, and they cannot, for the life of them, figure out how on earth galaxies stay together. Now, there are a few galaxies that do follow Newtonian and Einsteinian physics, but the rest of the galaxies mean nothing at all when it comes to this. And when quantum physics is used to try and explain gravity phenomenon, it is wrong more than a Googleplex in factors. It is wrong 10 to the 1,024 or something like that. It's 124. It's crazy. So, what is dark energy? Excuse me. Dark energy is the mysterious force driving the universe's expansion to speed up instead of slowing down, like gravity should cause. So, number one, how can galaxies possibly stay together? There's not nearly enough mass to hold galaxies together. There are 100 billion stars and 100 billion different galaxies, so you'd think physicists could explain that, but they can't. So that's number one. Number two is that, of course, the Big Bang 13.8 billion years ago, a grapefruit or infinitesimally small spot or moment of massively compressed energy. It goes out, it cools, it starts to shift into atoms and so on. And of course, that which is thrown out first should go the fastest. It would go the fastest, right? And then it should be slowing down because there's no gravity ahead of it, because space-time is literally being created by the expansion of the universe. There's no gravity ahead of it, but there's gravity behind it. So it should be slowing down, like Shatner, the end of a sentence. So It's not, though. The stuff that's furthest out is accelerating a little bit, little tiny bit, which makes no sense according to any physics. So they can't explain gravity, and they can't explain why gravity doesn't have any effect. In fact, it has a negative effect on that which is rushing away from the universe the fastest. It's accelerating. How could it possibly be accelerating? Unless there's a giant gravity mass beyond the edge of the universe, which wouldn't make any sense, or the fact that there's all of this trail of gravity, like stuff, behind all of this exploding stuff. Why wouldn't it be slowing it down? So physicists can't explain it. Now, listen, there's tons of stuff that can't be explained. We expect that. We understand that. That's not a huge issue. However, physicists have just, what's that famous Scott Adams cartoon? Next week, a doctor with a flashlight shows you where sales projections come from. Well, the physicists have just said, we're going to make up a bunch of bullshit. Well, we can't explain why stuff is accelerating at the edge of the universe. So why is the universe's expansion speeding up instead of slowing down? Well, we're just going to make up this bunch of abstract bullshit called dark energy. And dark energy makes up about 70% of everything in the universe. In other words, physicists don't have a single freaking clue about what's going on with 70% of the things they claim to exist but can't actually detect. Boy, that seems like an article of faith. I get that it does produce predictable and measurable outcomes, but nonetheless. Now, look, we all have to be kind with those on the frontiers of knowledge. Lord knows I've been a little bit on the cutting edge of philosophy for the past, 40 years. Probably closer to 20. But anyway, we got to be kind. But this stuff, this steaming pile of abstract bullshit has been going on for quite a long time. We'll get into the length of that in a second, right? So one of the biggest unsolved puzzles in physics is dark energy. Nobody knows what it is. It's, let's just say, it's a property of empty space. It's energy that is baked into the fabric of space-time. So as space grows, more dark energy appears, pushing things further apart. Maybe it's a changing field or something even weirder. Nobody has pinned it out. Why is it called dark? Because physicists can't see it. They can't measure it. They can only notice its effects on how galaxies move. They've tried going down to the center of the Earth. They've tried all these different things. It could be an asteroid-sized thing. It could be a smaller, this for dark matter. They tried all of this stuff to find it, like ether in the 19th century. Can't find it at all. Now, the universe's expansion, distant galaxies are flying apart faster and faster over time due to X-factor mystery juice called dark energy. The current expansion rate, called the Hubble constant, also applies to my ass as I'm pushing 60, about 70 kilometers per second per megaparsec. What is a megaparsec? Well, for every 3.26 million light years farther away a galaxy is, it's receding about 70 kilometers per second faster. So this is 10 to the power of minus 18 kilometers per second squared per megaparsec of distance. Absolutely tiny, but nonetheless. Recent data supports this acceleration, though some hints suggest dark energy might be evolving slightly. So the mystery juice that they have to squirt into their calculations to make them work, well, they're saying that it's evolving. So this is it's just mysticism. It's just mysticism. There's something out there that makes this all work. We can't detect it. We can type it into a spreadsheet or Mathematica, as a friend of mine used to use that. But we can't actually detect it in any way, shape, or form. It's just straight up mysticism. So, recent data from DESI using nearly 15 million galaxies hints that dark energy isn't perfectly constant. Instead of staying the same forever, like a cosmological constant, or like physics, its repulsive effect seems to be weakening over time. Hey, that's true of my philosophy show as well. Its repulsive effect seems to be weakening over time. Hey, I'm I'm not quite over my 40 years in the wilderness, but I'm getting there. So this dark energy was stronger billions of years ago, but getting slightly less powerful, especially in the last few billion years. This evolving model fits better than the standard one at about 3 or 4 sigma significance. Not quite a discovery yet, but intriguing. If it keeps weakening, it could eventually slow the universe's acceleration and even allow a big crunch way into the future. And there's a full survey from DESI completed in 2026, should clarify this. So that's wild, right? So, of course, the Big Bang started off with the singularity. Right? It sounds like something out of Deepak Chopra's armpit. Maybe it is. But it started with an infinitesimally small thing. Boom! It all explodes. Now, of course, the general issue in particular, because the galaxies at the beginning of the edge, they're all accelerating out in a very, very small acceleration, but nonetheless, then what happens is, it's called heat death, everything disperses. Entropy becomes permanent, right? So what happens is, stars explode, stuff gets dissipated, and eventually everything just gets so scattered and so far apart that nothing new can be formed because there isn't enough of an aggregation to collapse and start a new star and solar systems. Everything just gets spread out. Everything gets almost infinitely cold and quiet and distant. And of course, nothing can be supported as far as life goes without some massive amount of artificiality. But energy dissipates, light slowly fades, and the universe just keeps expanding, and there's nothing. The stars will all be gone. You won't be able to see any galaxies. There won't be anyone to see anything because there'll be no concentration of energy anymore, as in black holes or Class M planets or planets in the Goldilocks zone where life can emerge and so on. So, that's really a fascinating thing in a way. I could talk in trillions of years, I think, right? Or certainly billions, perhaps trillions. So everything just keeps expanding, and then everything just kind of winks out over distance. Like, you ever do that thing where you're driving away from something? I used to do this when I was a kid. If I look out through the back window, and you're just like, I can still see it. I can still see that store that we stopped at. I can still see it. I think it's gone, right? Or like you watch the sun go down. It's like, gone, right? And so the universe has a beginning because you can see all the background radiation. You can see all of the expansion and so on. So the universe had a beginning, and it's apparently just going to spread and spread and spread until heat death occurs, and there's nothing. The matter and energy is still there, but it's so ridiculously dispersed that you can't get any new concentrations, which would be required for life. So if the universe goes on and on forever, why would it have a beginning? Well, another option is that the Big Bang ends up becoming a big crunch. So stuff goes out, and then the mystery dark matter fudge juice of the Excel spreadsheet universe model, it changes. And it's the big crunch, right? It's the Big Bang, and then the big crunch, like this giant cosmic heartbeat that goes on for a trillion years or whatever it's going to be. It expands, it collapses. So then you can sort of understand, like right now, it doesn't look like it's going to collapse again, but it could if dark energy changes things. So, Big Bang, of course, the entire universe has started out extremely hot and dense, like me in my teens, hot and dense, about 13.8 billion years ago, expanded and cooled. So this is all space, matter, time, energy, all crammed into a tiny point, suddenly began expanding, like a balloon being blown up. As it expanded, it cooled down, the stuff inside formed into atoms, stars, galaxies, and eventually us. It wasn't an explosion in space, it was the expansion of space itself. Kind of like, you don't say what was before the Big Bang because the Big Bang created time. It's sort of like saying, well, what is north of the North Pole? Well, there is no such thing as north in the North Pole. It does seem odd to me because if you take matter and you compress it into something like a neutron star, which is one of the most dense forms of matter, all the universe would still be larger than the solar system. So it's hard to how did it start from this super dense, super hot state? About 13.8 billion years ago, everything we see today was compressed into an extremely dense point. Something triggered that point to start expanding rapidly. It's been expanding ever since. And I said, like, how can all the matter? I was like querying, how can all the matter in the universe be contained in a tiny point? No, it wasn't just matter. It was all of space itself. The tiny point wasn't matter squeezed into some empty space. The entire universe was that tiny point. Space didn't exist outside of it. Think of it like this. There's no container. The whole universe, including space, time, and all matter and energy was compressed into an incredibly hot, dense state, smaller than an atom, right? And of course, like, how could you have all of the universe in something smaller than an atom, and so on? And of course, nobody knows if it was infinitely small. The singularity is just the point where all the math breaks down. Like, beyond that, it's like light trying to escape a black hole, right? It's called a black hole because it's super dense and light can't even escape the gravity well. And so nobody knows. Just the math breaks down, and beyond this, it's like the here be dragons, right, in these sorts of things. So the observable universe has roughly 10 to the power of 53 kilograms of ordinary matter. If you stripped away all the empty space inside atoms and crushed it to neutron star density, the densest stable matter we know of, it would form a ball about 10 to 15 billion kilometers across the diameter of the solar system, like out to Uranus or Neptune and so on. So, doesn't really seem to make sense. So, the matter didn't get created out of nothing. It was just that the energy got transformed into matter as it expanded. So, the thing that outraged me as a whole, and we'll get into some more details as we go along, there is no accepted evidence against the Big Bang. I mean, it's pretty much accepted, right? There's sort of three pillars. The expansion of the universe, the cosmic microwave background, and the abundance of light elements. This is the proof of all of this, right? So dark matter is this invisible stuff that provides the extra gravity to hold galaxies together. There's no evidence of that properties changing over time. Dark energy is the mysterious force causing the universe's expansion to speed up. Dark matter appears stable because you don't need to change the variables in the equation. It's dark energy whose strength might possibly be changing. So with dark matter, astronomers measured how fast galaxies and galaxy clusters rotated. They found that the visible matter, stars, gas, dust, doesn't have enough gravity to hold them together. The galaxies should fly apart. So then they said, well, there's got to be a large amount of stuff at the center of the gravity that holds it together, center of the galaxy that holds it together. It's called dark matter. We can't see it, but something has to be there, or force equals mass times acceleration, Einsteinian, Newtonian physics of momentum and inertia and energy and gravity. None of this makes sense at all. So dark matter was invented because physics doesn't work with galaxies. Gravity doesn't work. And so I said to AI, that seems like fudging the numbers. Because people are basically saying, well, we're seeing something that doesn't make sense with the amount of matter we can see, so we're just inventing a huge amount of invisible stuff to make the math work. That's a fudge, man. I mean, I did sales projections. I did projections of business expansions and so on. I know fudge packing when I see it in this particular concept. So some physicists don't even like the dark matter thing because they say it's a total fudge. They work on modifying gravity itself to explain galaxy rotation without adding invisible matter. However, it's not a small amount. It's like if you need to fudge 5%, I'm like, okay, so you're 95% accurate. You're 95% accurate. However, for physics to work, this invisible, made-up armpit matter has to be 85% of the matter in the universe. Yeah, now that's a lot. That's a lot. So if you combine dark energy with dark matter, which is made-up stuff with made-up stuff, physicists can only really see and explain about 5% or so of the of the universe. That seems like quite a big fudge. Now, we can, of course, say, well, but sometimes physicists bookmark stuff. Like they didn't find neutrinos for over 20 years. The boson-Higgs particle was theorized and used in calculations, but it took, I think, 50 years or so to find it. But the dark matter stuff, the dark energy is newer, it's in the 90s. The dark matter stuff is over 90 years old. Like for over 90 years, they've been like, well, yeah, we're going to have to jam 85% of made up bullshit into our equations to make them work. And they've been trying like crazy to find it. And by the by, the capacity to detect particles and energy and waves and light and you name it is millions of times greater now than it was over 90 years ago. So, I mean, it's not the same as faith exactly, because if you plug all of this made-up stuff into the equations, it explains a whole bunch of stuff. Well, it doesn't really explain it, but it works out a whole bunch of stuff. And it makes testable predictions keep getting confirmed, so I get all of that. And one of the theories is that because occasionally you find galaxies that do work from a gravity standpoint, so they must not have this dark matter in it, and the galaxies that couldn't work without dark matter, that's kind of evidence for them having dark matter. So, but yeah, it's not satisfying. And there has been almost a century of searching for this kind of stuff, and bad though dark matter is, dark energy is even worse. Ugh. So, with dark matter, at least there are multiple independent lines of evidence that all point to the same thing. With dark energy, way more fragile. So, scientists are basically saying the universe is accelerating when it should be slowing down. So we're just going to invent this invisible energy that makes up 70% of the universe to make the math work. Well. Unlike dark matter, we have almost no direct evidence for dark energy. No idea what it actually is. We know something is pushing the universe apart faster than expected. So, yeah, they are fudge factors. And so I said to the AI, it seems like that cartoon where the scientist is pointing at the blackboard and saying, well, here's where a miracle occurs. And the AI said, haha, yeah, that's actually a pretty accurate way to describe it. A lot of physicists quietly feel the same way you do. When you step back, the current model basically says, okay, here's how it works, man. Normal matter, we're going to peg that at 5%, because 6% would be reaching. 5%, then there's this dark matter stuff we can't see that makes up 25%. Then there's this even weirder dark energy that makes up 70%. Don't ask what either of them actually is. So they're seeing clear effects, right? Galaxies spinning too fast, the universe expanding faster and faster, but they can't see what's causing those effects. So they basically said, okay, we're going to call it dark because we can't see it, and we'll treat it as the cause until we figure out what's really going on. So dark energy and dark matter, they're just placeholder names. That's it. There's scientists saying, well, we can't say bullshit because, we get government funding and we need to be able to speak to the kiddies. But it's basically, we're just going to make up a bunch of stuff to explain why things don't work. They are naming the mystery, they're not solving it. So the neutrino, as I mentioned, it was proposed in 1930 as a placeholder to fix problems with energy conservation and radioactive decay. Scientists treated it as real for calculations, even though they couldn't detect it. It took 26 years before it was finally observed, from 1930 to 1956. Higgs boson, another case, theorized in 1964, not discovered until 2012, a gap of nearly 50 years. So dark matter has been a placeholder for over 90 years now, which is longer than most of these examples lasted. Now, of course, you can't just change the constants, right? So the traditional ways of measuring, calculating, and anticipating or predicting gravity and the effects of gravity works on Earth, again, we step on our scale. So we can't just say, well, we're going to crank up gravity by 5 times, the power of gravity by 5 times to explain why these galaxies stay together, because then that would put me at, close to 1,000 pounds. What am I, 190 and change or something like that? So, yeah, we can't just do that, because if the more you crank up the gravity constants to take into account, say, well, they would fly apart, so we're going to crank up the gravity constants, then the solar system no longer works. Because gravity works in our solar system, on Earth, every lab experiment that's ever been done. And so if you change the gravity equations to fix gravity rotation, you break everything that you can actually test up close. Dark matter lets gravity stay exactly the same on small scales, while only changing how it behaves on the massive scale of galaxies. And that's a big problem, right? Because even though they haven't sent a spaceship close to the speed of light to figure out time dilation, and as you get faster than the speed of light, you convert more of the energy gets converted into mass. But they have put an atomic clock on an airplane, sent it around really fast, and they've measured a difference. So even though it's been they can still measure Einsteinian effects of relativity. So why is it completely absent from us, from our solar system, which is a pretty big old thing, right? It's a pretty big old thing, our solar system. And why is it that you can't find it? It has no effect, can't be measured in any way, shape, or form by anything local. It's just when you get to these big grand scale things that you desperately need it, and you desperately need it to a very large degree. To a very, very large degree. I mean, the dark matter stuff, 25%. I've heard more, I've heard less. I don't think that anybody knows, of course, like that. And the other thing, too, like two of the most successful theories, in my humble opinion, as a guy who's just interested in science, I'm far from an expert, but the 2 most successful theories have been quantum physics and the theory of evolution. I mean, I know that's biology, but, it's still in science as a whole. I mean, the computers all work on quantum theory, and it's been really fantastic. Dark matter? Nope. No effect whatsoever. Zero impact on everyday physics or technology. It doesn't affect how your car works, your phone, GPS buildings, or anything in normal life. Its only real, quote, use is in astrophysics and cosmology. It helps scientists understand how galaxies form, how they rotate, and how the large-scale structure of the universe developed. So it is not anything of any use to anyone. Dark energy is the same, zero practical use in everyday life. It only becomes important on the very largest scales, the scale of the entire universe. No measurable effect on our solar system, our galaxy, or even our local group of galaxies. So, like dark matter, dark energy is purely a cosmological phenomenon. It doesn't affect anything about anything that works on Earth, in the solar system, even within our own Milky Way galaxy. Its only role is, and AI keeps doing this tricky stuff, right? Because its only role is explaining why the universe as a whole is accelerating outward, which it doesn't do. It doesn't do that because it's not an explanation. It's just a fudge factor. Well, if we change the numbers, we get good results. So that's wild. That's wild. Let's do a little bit of history, because I find this stuff interesting. I hope you do as well. And then I'll get to my real rant. So dark matter was coined in 1933. A Swiss astronomer, Fritz Zwicky, was studying a big group of galaxies called the Coma Cluster. He measured how fast the galaxies were going around each other. Using simple gravity rules, he calculated that there should be far more mass in the cluster than he could see in the stars and gas. Without that extra mass, the galaxy should have flown apart long ago. He called it dark matter. The idea was largely dormant until the 1970s. In the 1970s, American astronomers Vera Rubin and Kent Ford were studying individual spiral galaxies. She measured how fast stars were orbiting at different distances from the center. According to normal gravity rules, the stars further out should have been moving slower than what was observed. It was as if the galaxy was surrounded by a halo of extra mass. And it's a huge disparity. I've got a little chart here. It's a huge disparity. From the 1980s to the 2000s, other evidence showed there was more mass than was observable. Gravitational lensing showed that light was bending more than expected as it passed by galaxies or clusters. So one of the famous proofs of relativity was in an eclipse, I think it was in the 30s, where the starlight was measured to be bending around the sun. Computer simulations that tried to explain the formation of galaxies and clusters after the Big Bang needed more mass to get the right results. The bullet cluster was a collision of two giant clusters of galaxies. The ordinary gas was slowed and stayed in between the clusters, but gravitational lensing again showed that there appeared to be more mass than was expected. So there was something going on in the universe that was not understood. So one problem with dark matter is that so far it's never been found. No experiments have yielded any positive results. The amount of dark matter in the universe is theorized to be, we had 75%, 85% of all matter. But all physicists have been able to do is rule things out. The standard model of physics predicted by the Higgs boson, but the standard model of physics predicted the Higgs boson particle, but the standard model does not deal with gravity at all, so it cannot be used to make predictions on these particles. So the way the equations are made to work is that the extra mass is added into the equations. It's a giant fudge, a factor. We can't explain it, but here's how we make the math work. We just imagine that 85% of all that exists is something we can't detect in any way, shape, or form except in the movement of distant galaxies and clusters. Well, and there's no practical value to any of this research whatsoever. I mean, if you're interested in the deeper mysteries of the universe, that's fine. I'm interested in the deeper mysteries of philosophy and ethics and free will and simulation theory, and I find all of this stuff absolutely fascinating, but I'm not holding the taxpayer-funded gun to the heads of the productive to force people to fund what it is that I do. So it's publicly funded, which means it's taken from the taxpayers by force, it's taken from the next generation through debt, and it is taken from the poor in particular through inflation. So it is really, really terrible. This is hobby stuff. This is not funding stuff. Again, if you want to fund it for yourself, that's fine, but I hate being forced to fund this kind of stuff at all. So dark energy. Dun, dun, dun. 1998, observations of the distant type Ia supernova showed that the universe's expansion was accelerating over time. This was, of course, surprising. Gravity should be slowing things down. Something appeared to be speeding it up. The simplest explanation, built into the standard lambda cold dark matter, that would be a fantastic tiramisu, wouldn't it? Model is the cosmological constant, lambda. This is a constant energy density that exists even in completely empty space. It has negative pressure, producing a repulsive gravitational effect on large scales. This is what is called dark energy. So a constant energy density that exists even in completely empty space that has negative pressure. That's just made up because they can't find it, they can't detect it, and there's no theory. There's no theory that says prior to making these observations about the speed of expansion increasing of the universe and the fact that there's no way that there's enough mass to hold most galaxies together, there's no one who would have had to come up with this constant prior to that, right? So now they found all these things. Well, we're just going to jam in a bunch of multiples here. That's not science. That's not science. So main problems with dark energy. 1, the cosmological constant problem, severe fine-tuning. Quantum field theory predicts that empty space should have an enormous energy density from virtual particles. The predicted value is roughly 120 orders of magnitude larger than what we actually observe. For the cosmological constant to match observations, it has to be fine-tuned to an absurd degree. This is widely considered one of the worst predictions in all of physics. So now we're in the realm of climate change modeling. Now, please understand, I say this with all humility. I'm not any kind of big expert in this area, but I have literally programmed environmental models back in the day. It was an environmental company that I co-founded. So I have done some, obviously, very rudimentary compared to all of this physics stuff. I've done, and you can get anything out. You just tweak the variables until you get what you want. It's the same thing with business plans. It's the same thing with a wide variety of things, right? I mean, if you've ever tried to figure out how much you need to save for retirement, and what you do is you say, okay, well, let's say I get 5% ROI. Okay, I need to save this much. What if I get 8%? Ooh, you can just change the numbers, right? And there's nothing wrong with that, but let's not pretend that these are facts. The coincidence problem is also a problem with dark energy. Why is the density of dark energy roughly the same as the density of matter right now? In the past, matter dominated. In the future, dark energy will dominate completely. We happen to live at the brief moment when they're comparable. This feels suspiciously coincidental, unless there's some deeper reason. No microscopic understanding. Unlike dark matter, where we at least have gravitational evidence in candidate particles, we have no idea what dark energy is made of or how it works at a fundamental level. It could be a constant property of space, a new dynamic field called quintessence. Also Robert Shaw in Jaws, a modification of all gravity on cosmic scales, or something else entirely. Recent observational tensions. This is kind of new and kind of important. The Dark Energy Spectroscopic Instrument, that's the DESI I referred to earlier, results from 2024 and 2025 show hints that dark energy may not be constant. That's right. It started twerking. When combined with supernova data, there is up to a 4.2 something evidence that dark energy is evolving. Its strength may be changing over time. Now, if that's kind of cool if that's true, because that would explain why there could be a big bang followed by a big crunch. I kind of like that. It all just jams again and you just hit rewind and start it all over again. If confirmed, this would rule out or heavily modify the simple cosmological constant model and point towards new physics, because if constants that are more foundational than anything we've ever seen before, because it is a massive amount, 85% or whatever of matter or of energy, then if you've got foundational constants in physics that are just flicking all over the dial, changing over time, then physics gets a little freaky. So, what is all of this? What is all of this made up bullshit costing you? Well over $1 billion a year in the United States Department of Energy High Energy Physics program directly funds both theoretical physics and experimental work in particle physics, dark matter, cosmic frontier, neutrinos, cosmology-related projects, and supporting R&D. It's the primary U.S. public funding stream for the topics we've covered. The CERN, they just shut it down now. People saying time is different. CERN got an annual budget of $1.4 to $1.7 billion U.S. Funds a large Hadron Collider, operations and upgrades, large experimental collaborations, theory groups, and related infrastructure. So, yeah, that's $3 billion. $3 billion, right? Oh, yes, but per taxpayer, yeah, you can say that about just about anything, except entitlement programs. But, if you think, well, it's only $10 or $20 per taxpayer per year, it's like, then go ask them. Trust me, as somebody who's trying to fund philosophy by asking people for things, it's not the easiest thing in the world. Really, really important. freedomain.com/donate. Tip.freedomain.com. You can see that right there on the screen. But freedomain.com/donate to help out the show. I even give lots of great goodies. You get lots of different AIs programmed on all of my cool stuff. You get Bitcoin AIs, real-time relationship AIs. You get really cool, great AIs. You get hundreds of premium podcasts, private shows that we do just with donors. Really, really great stuff. freedomain.com/donate. So all of the people, and I bet you all of the people who were like, well, it's only $20 or $10 or whatever it is per year per taxpayer, it's like, it's not easy to get people to support. I'm not getting $3 to $5 billion per year. Not even half that, technically. So this is the global rough total for particle physics, high energy physics, cosmology, and astroparticle physics including dark matter and neutrino experiments, about $3 to $5 billion US per year across major countries and international organizations. Most of this money supports experimental facilities, detectors, operations, and computing. Theoretical work receives a smaller but non-trivial share. Dark matter direct detection experiments. Panics. I'm not having a stroke. I'm just reading out the acronyms. Planned next-generation detectors represent a smaller subset. Cumulative global spending over the past 2 decades is in the low billions. Individual large projects typically costing $100 to $400 million to build. Infrastructure costs. CERN. $6 to $7 billion in today's dollars to build. High luminosity upgrade, $950 million. About 1.1 billion. 950 million CHF. That's chafing. It's the economy that happens when your mom does your tidy-whities and uses too much starch. You get chafing. 7-9 billion in recent dollars for all of this sort of stuff. Anyway, we can sort of post this. It goes on and on and on. Last 20 or 30 years, it's been a lot. It's been quite a bit. Tens of billions of dollars for sure. Tens of billions of dollars. Now, you can say it's per taxpayer, but I mean, tens of billions of dollars is you for 200 generations paying taxes for all of this stuff. And there is a kind of thing as well. Also, energy consumption is huge for this kind of stuff. So if people want to do it, that's fine. I mean, again, I absolutely understand that people are going to have kind of cool stuff that they want to do. Yeah, that's great. And no problem. I understand that there's cool stuff that people want to do, and they should do it, and they should fund it themselves, and they should stop playing ookie cookie with the taxpayer dollars and coming up with a whole bunch of nonsense and made up stuff and pretending that this is science. And part of the reason that this bothers me is because there are a lot of scientists, the majority of scientists out there, thumbing their nose at religion because they're saying, how dare you? How dare you have faith in something you can't see, touch, taste, smell, and that there's no evidence for? Now, you could say, yes, but there is evidence for something because of the way that the galaxies work, and there is evidence for something because the acceleration is increasing when it should be decreasing because there's no gravity well ahead, there are only gravity wells behind. But what bothers me is the scientists say to Christians, they say, well, you say that God made us, and that's not an answer. Okay, dark matter and dark energy are not answers. They should call them Fudge Factor 1 and Fudge Factor 2, because when people hear dark matter, they're thinking something like antimatter or something that's been proven. Dark energy, it's, something that is like a negative energy, but they don't know really what kind of matter it might be. They don't really know what kind of energy it might be. They've spent, the dark matter stuff has been known for, again, it lay dormant for a while, but that's probably for a reason for that too. Everyone went to the Manhattan Project. But it is rich for scientists to say to other people that you believe without proof, you believe without evidence, you believe without reason. And I don't think scientists have been very upfront with the fact that they've been sitting on this thing for almost 100 years. That is just a complete fudge factor that they have no idea what it is. It sounds pretty cool. I'm wrestling with dark energy. I'm taking aim at dark matter, as opposed to we're trying to find evidence of a total fudge factor we put in because we don't have a clue what's going on. Here a miracle occurs, and there the numbers work. Well, Were you aware? Maybe you knew. Maybe I'm behind the curve. Did you know that 95% of matter and energy is made up to fit equations because they can't make things work? Are you aware? Now, I understand that. Look, first, let me say two things. Einsteinian physics is fine for sailing around, flying planes and stuff like that. Newtonian physics is fine. Einsteinian physics is great for, sending Voyager out of the solar system and things like that. And so, but that stuff's all measurable, and that stuff's all, I get that you have the level of accuracy that you need. You don't need Einsteinian physics to sail from Dover to New York, but you do need Einsteinian physics to get a spaceship out of the solar system. So I get all of that. But this stuff is just made up. It is a bookmark for an absolute void in proof, reason, evidence, and understanding. You say, but there has to be some matter there. It's like, but you can't use the word matter and energy for something you can't detect. It's like calling a doorway a dark door. It's like, no. A doorway is not a dark door. A doorway is no door, or a door open, or but an archway, right? You see, the air. All I need is the air that I breathe. The air through which my words puff and through which my arms wave. That's dark concrete. It's like, no, it's not. If it was concrete, I'd be Han Solo frozen, unable to move. It's not dark concrete. It's stuff that ain't there. Now you can say, yes, but it has to be there because that's needed for the math. It's like, but it ain't. Now, matter is something you can detect. And we're not talking about a neutrino, which can slip through the fingers of detection equipment very easily. Right? It's like Ferris Bueller coming out of the goop at the beginning of Greyhawk. Matthew Broderick. That's what I can think of his name. So, yeah, I get you can slip through Butterfinger's detection equipment, Higgs boson and neutrinos. I get it. But we're talking about 25% of the entire universe you're calling matter that you can't detect in any way, shape, or form. You can't use the word matter. Oh, yes, but we've modified it with dark. It's like, that's not enough. It's not honest. It's not direct. And again, I have no problem with bookmarks in the mind for things that haven't been proven yet. Of course. That's to have a standard that says everything has to be proven immediately is false, unrealistic. Of course, we're going to have bookmarks. Absolutely. I talked about ethics and virtue for 20 years before I proved them with UPB. So I'm not having any problem with that. But the problem is that the scientists, not only are they sucking the bloody teat of taxpayer money from here to infinity, but they're not being honest. It's not dark matter. It's not dark energy, because matter and energy can be detected. Well, it has to be there. Okay, it's not a neutrino. It's 25% of all matter. And up, and up, and up. That's not a small amount. It's a massive amount. And when you combine dark matter with dark energy, scientists can't explain 95% of what is. I'm not saying that means there's a God. I'm not saying that God is a better answer. I'm not saying that at all. I do have a bit of a problem with these Big Bang Theory turbo nerds thumbing their nose at religion when the inverse pyramid of modern physics, at least in the intergalactic sense, seems to be based on enormous amounts of made-up fudge factors. Maybe have a bit of humility. Maybe say, oh yeah, people in religion believe in stuff without evidence, but so do we. At least there's some evidence of the effects of matter in the galaxy rotation stuff, but The dark energy stuff is just a complete made-up fudge factor for which there's no evidence, and, by the way, for which there seems to be evidence that it is a constant that changes, which is a contradiction in terms. You can't dial up and dial down gravity on a whim. So I think that there would be more common cause between scientists and religion and saying, listen, you guys believe in a bunch of stuff without evidence, but so do we. You guys have a fudge factor called God, but we have a fudge factor called dark matter and dark energy for stuff that has the exact opposite properties of matter. Oh, and by the way, the exact opposite properties of energy. But we've got a void filled with anti-gravitational bullshit. I mean, I get that physics kind of blows your mind. Newtonian physics, yeah, not so much, obviously, but Einsteinian physics definitely starts to blow your mind. But this stuff, space isn't empty. It's full of anti-gravity made-up stuff that we need to explain the expansion of the universe accelerating rather than decelerating. My God. All right. Thank you for my rant. Scientists should be more clear that they do not understand 95% of the universe. They should be more clear about that. Because it's a little shocking. I mean, maybe you knew all of this stuff, but it's a little shocking. How dare those religious people believe in things they can't prove? And also, if all that physics in general, if all that physics has to offer is a universe that has a beginning but no end, I mean, it has entropy, but that's not the end of the universe, then for them to say, well, but the idea of God is crazy. Like, well, why was it 13.8 billion years ago and not 14.8 or 12 or whatever? Something had to get this wind-up toy started. Say, oh, well, maybe stuff popped in from another dimension. I mean, I've read this sort of stuff. Well, maybe all the matter popped in from another dimension. Yeah. Come on. It makes religion look a whole lot less faith-based and contradictory and requiring a whole bunch of belief in things that can't be proven as self-contradictory and don't exist, but you believe that they do, because they say, yes, but we can see the effects of dark matter in the orbits of galaxies. And they say, well, we can see the effects of God in the human mind, and the human eye, and blah, 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 blah. So I feel a bit scammed. I mean, I feel scammed as a taxpayer, obviously, but I feel a bit scammed that scientists have been talking about a lot more frickin' certainty about things than they have. If 95% of your work is based on giant fudge factors, I understand. Locally it works, I get that, Einsteinian, Newtonian. Locally it works, solar system it works, this galaxy, I get that. But we're talking about all of the universe. Physics has a bunch of made-up fudge factors, a bunch of self-contradictory stuff, and constants that appear to change over time. Why would those constants change over time without some external influence? Maybe that external influence could be called God or something like that. But calling it dark matter and calling it dark energy is no more clarifying than calling it God. They could call it God, God's finger flick, that's it. God's armpit hair and God's finger flick. They could call it that, and it makes as much sense. In fact, it's less deceptive than dark matter and dark energy, which indicates that they have some matter and energy to study, which they don't. Oh, nerd rage. Not mine, theirs. Nerd rage against religion. It bothereth me. I've watched a little bit of Big Bang Theory back in the day in idle moments, and those guys always bothered me too. Always bothered me. The vanity, the certainty. And why don't they give good dialogue to Christians about this kind of stuff? So It does seem to be kind of annoying. All right. Let me get to your comments and questions. If you are on X, of course, you are welcome to call in. And of course, if you know about these things, feel free to set me straight where I have gone horrendously astray. All right. Somebody says, getting more familiar with your work as of late, very insightful. I am not a D&D nerd. I read familiar as acquaintance with closeness, not as a beast on your shoulder that helps you with battles. All right. How many premises and conclusions are there in a syllogism? Well, it really depends how long you want the syllogism to go. Was Descartes' demon not just a thought experiment? So it's called Cartesian in terms of the flow through. But no, it wasn't just a thought experiment. He wanted to know what he could be certain of if he assumed everything around him was a lie. What could he be certain of? He wanted to build certainty from the ground up. And I think, therefore, I am, is basically, even if all of my senses are fooling me, even if I'm a brain in a tank being manipulated by an external malevolent demon or something like that, then at least I know that I'm being fooled. All right. Now, James is going to call in and is going to correct me on things that I got wrong and save me from myself. All right. James, sup?
Hello.
Hello.
Yeah, so I was doing the research and I definitely ran out of time because I was spending way too much of that in the rabbit hole trying to understand what in the world dark energy was actually, dark matter rather, was trying to actually, like, why was it even suggested and what have they actually done to try to figure it out? And so I didn't get to add too much. I didn't get to add some of the questions. You touched on one of them, which is, if dark matter is this 85% roughly of observable energy, just, or matter and energy in the universe, like we got 5%, 25%, and then we got the 70% of dark energy. Just set that aside. And it's like, we should be awash in this stuff. Why can't we detect it? And so, unfortunately, the AI kind of said, well, like neutrinos, we know source is neutrinos, right? Because we look at the sun or nuclear reactors or, cosmic rays. But we don't have a direction. It's like, but. And it gave some sort of measurement, which I don't particularly understand about the density of dark matter. Because I was asking the question, okay, so our universe, our particular galaxy seems like it's probably one of those that are more typical. Because there are some examples of these galaxies that don't have, like some of them do orbit the stars in a slower fashion as they'd expect. But even so, I mean, it's interesting. I mean, I enjoy every once in a great while the mental exercise of visualizing, like from looking at the Earth, like from the North Pole, and look at the solar system and trying to say which way is the moon going around the Earth, And it's like where's the moon right now in relation to the Earth and the sun? And of course, I'm not going to get it right, but so I enjoy the nature of reality, the stuff that's not obvious to us, and I do thought experiments on that kind of thing.
Oh,
But,
every now and then I enjoy standing under a night sky and willing myself to understand that I'm on the slippery side of a spinning planet.
Excellent.
Right, rather than being fixed, because that's our standard, right? Fixed and firm. So I absolutely enjoy willing myself to see the universe as it is, and it's kind of freaky. So I get what scientists are doing, and I appreciate that. And sorry, just before you continue, I wanted to just be clear. The dark matter is about 27%, dark energy 68%, ordinary matter is 5%. So dark matter 27%, dark energy 68% of sort of matter and energy, and that adds up to 100%. So dark matter and dark energy make up about 95% of everything. We can just go with roughly 25% dark matter, 70% dark energy, and 5% ordinary matter. Because I heard the dark matter stuff kind of floated around. So 25, 70, and 5 is what we should probably go with. So just go ahead. Sorry.
Oh, sorry. And when I said, I think 85 is what I said, that's like if we just ignore dark energy because there's no way to detect that at all, according to any experiments. What they've been trying to do for dark matter is to say, okay, if you take that 30%, well, it's a 6-to-1, right? Or no, 5-to-1, sorry, 5-to-1, 25-to-5. So it should be all over the place, is what I was getting at with that.
It's giant enough energy that it holds entire galactic clusters together. It holds entire galaxies together. And you're right, it's 5-to-1 with ordinary matter. And you can't find it anywhere. It keeps it's like the force. It binds the universe, holds the universe. You can't find it anywhere. And yet it has an effect on matter. So it has to have some matter or some energy to have an effect on entire galaxies. How can it not be found at all?
Yeah. It's like, well, it's diffuse. And it's like, how, I was like, okay, well, how is dark matter sort of distributed? Is it uniform? That doesn't seem like that would make any difference. So if it's all in the center, that wouldn't change anything. So the explanation I got from AI, like this is the theory, obviously nothing is substantiated, is that it extends beyond the galaxy in a quote halo. Because the other thing is, I'm like, okay, so how does this actually speed up plans? Because I didn't really get that. And I think
so they're saying that the stars on the sort of whirlpool arms of the galaxies are going too fast. Is that right?
Yeah. That was the thing that the researchers in the 1970s stumbled upon, which is how dark matter sort of reemerged as a thing, with any prominence. So yeah, it's like, you saw that graph. For anyone who didn't see that graph, it's basically the orbital speed of an object goes up pretty sharply, and then it sort of falls off. It's basically like I don't know if you say like a parabola or like inverse parabola, something like that. If that makes sense to people. But in galaxy, the observed speeds of stars as they get further out keep like a really fairly constant sort of velocity around the center of the galaxy, which is again not what they expect. It's like, okay, there's got to be some explanation for this we don't know, and of course the dark matter is the we don't know, but
but they put it in
anyways.
a sort of Saturn's ring around the galaxy in order to explain the speed of the stars on the outside. I'm not quite sure I understand that, because wouldn't that just sort of pull them away from the galaxy as a whole?
Well, so the way it would be in orbit, my understanding, of course, again, layman, blah, 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 is that if you have something that's further out, like how the period of Mars around the sun is this 400 something days, something like that, compared to our 365. In order for it to not shoot out of orbit, it has to go at a slower speed. So it means takes longer to rotate around. Well, it's a larger distance, but it also moves slower, is the thing.
Right. Yeah. So this is from Grok. Dark matter surrounds galaxies in large, roughly spherical structures called dark matter halos. I'm sorry. It would be so much easier to be in business if you could just make stuff up. These invisible halos extend far beyond the visible stars, gas, and dust of the galaxy, providing the extra gravity needed to hold everything together. Okay, I am not a physicist, and maybe maybe other people can tell me. If you've got this dark matter surrounding the galaxies, wouldn't that cause the galaxies to disassemble as they flow towards the gravity well of this dark matter? I don't understand. How do they? I can understand if they're in the center, and maybe I can ask about that. But why dark matter forms halos? Dark matter interacts only through gravity. It doesn't emit, absorb, or reflect light, and it barely interacts with ordinary matter. As galaxies formed in the early universe, dark matter clumped first under gravity, creating gravitational scaffolding. Ordinary, baryonic matter then fell into these potential wells, forming stars galaxies at the center. The result is a galaxy embedded deep inside a much larger dark matter halo. They are roughly spherical or slightly flattened. Density is highest at the center near the galactic core and decreased gradually outward following profiles like the Navarro-Frank-White NFW profile. Halos expand many times further than the visible galaxy. For the Milky Way, the dark matter halo reaches hundreds of thousands of light years out, while the bright disk is only about 100,000 light years across. Smaller subhalos orbit inside larger ones, which can host satellite galaxies like the Magellan Clouds around the Milky Way. The strongest everyday evidence comes from how galaxies rotate. Visible matter alone predicts that stars and gas far from the center should orbit more slowly, like planets around the sun. That's your point, right? Instead, they orbit at a nearly constant high speed, even at large distances, implying massive unseen matter distributed in a halo. So, dark matter doesn't just surround galaxies like a shell, it permeates and envelops them in an extended gravitationally dominant halo that dominates the total mass, often 10 to 100 times more mass than the visible galaxy. This halo is what makes galaxies stable and it enables the structures we observe today. This is video game programming. It's not science. Sorry, go on.
Well, actually, as you were talking, I just thought of something. This is so obvious that someone had to have thought of it. But okay, so let's say that we're entirely suffused with dark matter all the way throughout, right?
Yeah.
Would there not be collections of dark matter inside solar systems? I bet you it doesn't work like that. But no, seriously, would there not be something like that? And so
No. So
the
James,
thought,
no.
go
So
ahead.
to get into, sorry to be annoying, I'm going to be Mr. Physicist now. To get
Go
into
ahead.
the dark matter mindset, James, where you cannot find the effects of dark matter, there is no dark matter. Where dark matter is necessary to explain things, then it exists.
Oh, I mean, okay.
I'm not
I'll
kidding.
just sort of,
That's how it works.
you're not kidding. Uh, really not kidding. Because what I was going to say was, should are any of our planets moving a little bit faster than they ought to relative to what you would expect based on their mass and position in the solar system?
No, because the halo is outside the galaxy. It is not outside our solar system.
Okay, give
And
me
you
names.
know that because the stars are going too fast in a galaxy, but the planets aren't going too fast in the solar system. So you only need the dark matter halo around the galaxy, not around the solar system.
Oh, you know what I bet it is? I bet you the sun's actually going again, like an oblique angle to the center of the solar system. That must be what it is.
And that's how we know global warming is real and you need to pay your carbon taxes, kids. Oh my! So, what was your experience of digging into this? That James and I talked about this earlier today, and we both sort of dove into it. And what was your experience of going down this dark matter rabbit hole?
Well, as with most, I did stumble across string theory at one point as well. One of your favorites. So yeah. So it was interesting. It was also, well, actually no. I say this at first. Grok threw a whole bunch of stuff that I had no rightful way in all the hells and heavens to actually process. Like, I'm a smart guy. I'm one of the smarter out there, but I'm not a physicist. I don't understand what the hell it was talking about. So I had to tell it, as I often do, dude, lay language, please, layman's terms. So uh, that started me off, and then unfortunately, I would bring up like, okay, so they're funded through stolen money, and it kept pushing this whole, well, we have to fund science essentially, not in those terms, but that kept coming up as well. But that aside, it was like, okay, so every time I asked it a question, I would get answers. And it's like, does that answer your question? Are you satisfied? I'm like, no, not really. And I think that's not a failing of the AI in particular. I think it's just a failing of theory because, I mean, look, it takes a really intelligent person. It takes a really intelligent person to come up with something really novel. It takes maybe a different kind of intelligence or even more intelligent person to be able to communicate that very complex concept in comprehensible terms to the average person, or at least the average lay intelligent guy, right? So I'm not going to blame Grok for that in particular, but it does definitely have a bias for like, yo, science, fuck yeah, right? So it's that, I mean, I'd say most of that is tedious, but it's fine. But I mean, it was interesting enough to sort of see, okay, how did this start? How, like, what are the challenges to it? Is it actually something observable or some completely made up nonsense? And so it's interesting to see that there is something in there And like you said, it's a label, right? It's a label for this isn't behaving like our equations. Our equations tell us it's behaving. Dark matter. I don't know what else to call it, right? Which
No, it's
I
just
guess
like
is fine.
certain racial groups don't do as well. Racism, and it's like no, that's not an explanation. That's just a label. Sexism. This is a label, and these labels. I this is going to sound like a stretch. Maybe it is a stretch, and tell me what you think, James. But I can't help but think that if the general public knew that scientists use 95% fudge factors, how do you think COVID would have gone differently?
Okay, and I'm assuming that another assumption I'll lay on that is people actually sort of pay attention to that. They don't just sort of shrug with that information. I mean, I think they're like, wait a minute, safe and effective. You've only tested this for 3 months. Like all sort of the things. I mean, that's just one of them. All the other things you brought up about, like lockdowns. Like, okay, was made in a lab? All of these things. I would
Yeah,
say there'll be a
if
little more skepticism towards experts.
when people say, "Oh, this novel mRNA mystery joy juice is going to totally protect you from a virus which has never been protected from before, and it's been tested for 3 months," like if people knew that physicists can't explain 95% of what's going on in the universe, then would people say, "Oh, I'm sure you know it's 100% effective, this therapeutic, right? This vaccine, the quote vaccine." Yeah, I think again, I've sort of put forward the idea that scientists are just like the new lab coat, white coat, mystery religion cult priests, right? That you couldn't talk to God, you got to talk to the priest, and the priest tells you what God says, and you got to. So politicians go to scientists, and scientists say something. You got to trust the science. Don't do your own research. I think if people genuinely knew that scientists have to create magical fudge factor angel wings to make galaxies work, and they can't explain why the universe's expansion is accelerating, and so they have to create 70% fudge factor. I think then people would be kind of skeptical about science, which I would like. I like skepticism as a whole. Yeah.
Oh, and science only functions because of skepticism in the first place.
Oh, it depends what you mean by functions. It functions pretty well if it can bullshit a bunch of people and get a bunch of bunch of government money. It seems to work pretty well.
Yeah, so shame on me for not defining my terms. Functions as in actually advances knowledge and benefits the world. I mean, benefits a small part of the world, but I meant sort of as a more larger whole, like technology, engineering, et cetera, et cetera.
Yeah, yeah. Okay. Well, listen, I'm sure we'll get a bunch of flambés from scientists. And listen, if you are a scientist, I've interviewed scientists before. I love chatting with scientists. If you want to call in, set me straight. Set James. Well, I'm fine. Set James straight. Let's just say set James straight. If you want to call in and tell us about how we're totally wrong, I mean, I absolutely concede that science is fantastic. I absolutely concede that what we're doing here couldn't work without science, and I absolutely love science. I'm just a little shocked to find out that 95% is absolutely unproven and made up fudge factors. And I don't mean made up like completely random. I understand when a little bit less with the dark matter, but with a little bit less with the dark energy, with the dark matter stuff. I just think scientists could be a little bit better at communicating that 95% of what's going on in the universe is just made up fudge factors, and that they can't detect it anywhere in any way, shape, or form, although they've been trying for almost a century with one of them. So. All right. Is there anything else you wanted to mention? I was going to go back to the Q&As, but I'm certainly happy to hear more.
No, I think that's good enough for now. I really appreciate popping on and getting a chance to sort of dig into something that's, for me, esoteric, but also, really interesting, like all the fakery,
Oh,
good
yeah.
stuff.
James, ladies and gentlemen, our trusty free domain co-worker, freedomain.com/donate. Bro needs to eat. All right. So somebody says, we're going to whiplash ourselves to a slightly different topic. What do you think about near-death experiences, like the woman who saw a shoe on the hospital edge while she was dead, and it was later confirmed by witnesses? Could there be a normal explanation? Yeah, sure. The consciousness cannot see. Our consciousness cannot see without eyes. We know that because when people are born without eyes, or their eyes get removed in some Kill Bill, Daryl Hannah fashion, they can't see. So the idea that the mind or consciousness can leave the body and see without eyeballs is not a valid hypothesis. Now, I obviously don't know what it's like to die. I know what it's like to kill my career, but I don't know what it's like to die. Then when people die, I assume there's a bunch of time dilation, there's a bunch of scrambled images. I assume it's probably the closest you get to waking dreams. Like when I was a kid, I was kind of obsessed for a while with trying to figure out, I really want to feel what it's like to fall asleep. I was really quite obsessed with that. I thought that would be the coolest thing. Of course, every single night I would say, okay, I'm getting tired. And I'd wake up. And then I'd just end up dreaming and I would never catch that moment of falling asleep. But I bet you when you're dying, assuming it's not like some decap situation, then you go through waking dreams and I'm sure you get a bunch of visions. And I'm sure that somebody got a vision of a shoe up on a ledge. And then they came back to life and there was a shoe up on the ledge. Absolutely. You need to understand coincidences. I'm sorry to be annoying and lecture head and all of that, but the typical example is if I'm walking and hiking and a fox crosses the path and I'm like, oh my God, I had a dream last night about a fox crossing my path. Oh my, goosebumps, right? And then suddenly you're living in a simulation where things can happen ahead of time and that, right? So, but of course, we all know the answer to that is that think of all the dreams that you have that don't come true, right? So you get one dream that comes true, quote, comes true. You don't think of all of the dreams that don't come true, and that's the reality. So all of the people who have visions as they're dying, one person had a vision of a shoe up on a ledge, and it turned out that there was a shoe up on a ledge. But think about all of the visions that people had when they were dying that didn't come true, right? So you just have to look at coincidence. Coincidence is not proof. All right. Boom. Somebody says, yes, it's the placeholder that has to exist for our formulas to hold up at a cosmological level. Sure. But you can't call something dark matter when it has no properties of matter at all. Oh, somebody enjoyed my I know fudge packing when I see it. Steph, do you think Nazism will come back to Europe? I don't think so, and I hope it doesn't. What we want to start moving towards is a free society, which we need to grow in humanity based on peaceful parenting. So spread peaceful parenting is the best thing you can do for politics. All right. Could be variable amounts of dark matter in different places. Yes. Sure. Absolutely. Why not? I could have an imaginary pile of gold over there. I could have an imaginary pile of platinum over there. And maybe they're changing and becoming heavier and lighter and moving through the air. My God, you might as well say fairies are pushing stuff. Well, we do know that it is accelerating, but we don't 100% know why. No, you don't any percent know why. So this is the kind of annoying fudging that I assume you're a scientist, and I'm glad that you're here and feel free to call in. But when you say we don't know 100% why, creating imaginary energy that makes up 70% of everything that is, and saying, well, it's a property of empty space-time that has gravity-repellent properties when there's no proof for any of that. It's not. I mean, you might as well say that there are invisible angels beating their wings and pushing matter at the edge of the universe faster and faster. All right. So you say placeholders. I get all of that. But you understand God is a placeholder too. And I do believe that people should be more honest about that. Sorry, this is the, I assume a scientist, dark matter does 70% of the physics despite being 13% of the textbook. Steffi from philosophy to physicist. It's so funny that people like using the diminutive, insulting form of my name, Steffi. I mean, it's so gross and vile and toxic. I mean, why would anyone do that? It's rude. It's kind of rude. Anyway, so somebody says, the scientist or perhaps scientist says, well, we are able to use those placeholders and perform research, assuming these are accurate, even if we don't understand it fully yet. No, you don't understand it at all. This is the vanity of the scientist. What do you mean you don't understand it fully yet? You don't understand it at all. He says, allows us to figure out other pieces of the puzzles like systems of equations until eventually we will figure it out. Hey, and listen, I mean, these are constants and facts and so on. And it certainly could be the case, and I'm sure that it will be the case, that at some point scientists will figure this stuff out. Maybe the equations are wrong. Maybe there is this dark matter, and maybe tomorrow dark matter will be discovered, dark energy will be discovered and proven, and so on. I get all of that, and I'm not saying that it's impossible to figure out, and I'm certainly not saying that it's mystical. I'm not saying it's God or it is angels beating their wings, but I don't think that people look at scientists and say you can't explain 95% of the universe and you're just making stuff up to make the equations work. Because the other thing too, if people knew that about physics, they would also understand that about global warming models. The global warming models are there to serve political purposes, to frighten children, and to control the population. Because they're constantly wrong. And what was it, a 20-year pause that was never predicted by any of the models? They're just constantly wrong. We need more research to figure these things out. Sure. Then people should fund that research as they see fit voluntarily. I hope more funding is attained. Unfortunately, to get that, you need to play the great game and beg the government. No, see, I would disagree. I would argue that if I was getting government money, I would not be doing these live streams. If I was getting government money, I would not be doing my call-in shows. If I was getting government money, I wouldn't be out there giving speeches when people were threatening to shoot up the place and blow up the venue, right? I wouldn't be working on philosophy that benefits people as a whole, that benefits people in their lives as they live. I would be doing a whole bunch of esoteric nonsense because I would not be humanity, customer, value, productivity, utility focused. I mean, if the government showed up tomorrow and said, we want to give you $1 million to do philosophy, I got to tell you, I know this sounds kind of goofy. I wouldn't even be tempted. Now, I have had people in the past offer me money back in the day, in particular before I got more controversial, right? But I did have people offer me money, build studios, get you on this, that, and the other. And I was like, I was a little tempted, like maybe 5%, but not really, because I want to talk to you guys. I want to get freedomain.com/donate. I want to get tips from you guys because that keeps me pointed at the productive marketplace of actual philosophy that changes people's lives. So in terms of like, we're going to go beg the government, I think what happens is physicists end up alienated, depressed, and with a desperate sense of non-utility. All right. There is most definitely a communication issue in astrophysics to explain to the layman. No, it's not. Not at all. Not at all. You're just padding the numbers with made-up stuff that you have no idea what it is. Everyone can explain that. I mean, most people, if you've ever had an expense account, some people pad that. We can't explain it, but the math seems to work out, so we're just making up a bunch of stuff. People can understand that, but they don't want to say that. He said, at least it's not as bad as the business world where they make up jargon out of simple concepts to justify their corporate bloat and jobs that do nothing. LOL, goo people. Ooh, you ranted son of a bitch. You absolutely ranted son of a bitch. Okay, the fucking business world is not taking anybody's money by gunpoint. For the most part. Right? So all of this physics shit is blood money, bro. Blood money. If people want to waste their money with bloat jobs in a corporate world, a lot of which is driven, of course, by government regulations, but businesses can't force you to do anything. See, the physicists are nerdy, tweedy, pocket protector Genghis Khans hunting down your money at gunpoint. So the physics shit, that is coercive based with the government. Business can't force you to pay. All right. Do you... somebody says, the same guy says, cycles of Big Bang and Big Crunch being most likely under current models. I don't quite agree with that. The Big Crunch seems quite unlikely unless they can find the rate of change of dark energy to suddenly start pulling the universe back, which would be an enormous amount. To decelerate the entire galaxies and start moving them back towards the origin of the Big Bang would be a level of energy that is scarcely to be accounted. It's scarcely to be considered. No human mind could possibly conceive of it, which doesn't mean you can't use math to describe it. But the amount of energy reversal that it would take to not just reverse, but slow down the increasing acceleration of matter at the edge of the universe that is increasingly getting faster and faster. It moves away. To slow it down and then to decelerate it, to get it back to an origin point, it's unbelievable. The amount of energy, and there's no explanation in physics that comes anywhere close, unless you start dialing up this made-up dark energy to insane levels. All right. Do you consider religious indoctrination of children to be child abuse? For example, if parents emphasize teaching their children hell and the wrath of God, does this constitute child abuse? Well, the simple way to do it is not to do it from that standpoint, if you don't mind me saying so. The simple way to do it is that if you got someone to do something by threatening to torture him for a full year, like, do what I want you to do, or I will kidnap and torture you for a full year, that would be illegal and you would go to jail. That would be a kidnapping threat. That would be a torture threat, a threat of grievous bodily harm. So it would be illegal to get people to obey you by threatening to torture them. Now, if you said, well, it's not me who's going to torture you, it's someone else, that wouldn't actually make it much better. In fact, now you just have criminal conspiracy. So when it comes to things like that, don't think about it in terms of parents and children. Just think about it as, would you be allowed to do that from a legal standpoint or a legal setting? Hey, Steph, are you really live? People keep saying this is a fake account. Well, I guess I just read that, so you can come to your own conclusions. All right. The science guy says, I think that putting your children in a private school or homeschooling them where they are fed falsehoods and are set back in terms of the wealth of knowledge that is assumed is abuse. Oh, so your assumption is that the amount of falsehoods that are told in homeschooling, if it's Christian, is greater than the falsehoods that are told in government schools? I would not agree with that. Homeschooling is much less destructive to children. Christian homeschooling is much less destructive to children than modern government education, which is absolutely horrendous, particularly for white males. It is very similar to much AI R&D right now. It is assumed to create economic payoffs, though through the discoveries later on. No, it's not similar to AI R&D. So AI R&D is largely privately funded. AI R&D requires the mass pillaging of intellectual property without acknowledgement or payment. It is absolute theft of intellectual property to run AI, but at least it's privately funded, and AI is producing things of value right now. All right. All right. Why did the man fall down the well? Couldn't see that well. That's funny. That's funny. I mean, science started with private funding, right? It was often business people or sometimes aristocrats who would fund it. Somebody says, Whenever I'm around my parents, I feel stiff and odd. They irritate me. I dislike them as people, college age, and I live with them. I feel so tense and I can't study. Physical abuse is a factor. I'm sorry to hear of that. Trust your body. Your body is very good at, we are just this like snowflake on top of a giant iceberg with Leonardo DiCaprio's sticking out of it. The conscious mind, very amazing and powerful. My general analogy has been the conscious mind is like a laser. It can really burn and focus, whereas the mind as a whole and the unconscious in particular is more like moonlight. It's a little tough to navigate, but it gives you a much bigger picture of what's going on than a laser. A laser focus, concentration focus. So if your body is rebelling against the proximity of your parents, I think it's usually a good idea to have a conversation with them and say, I feel kind of uncomfortable around you guys. I feel kind of tense around you guys. If there has been a history of physical abuse and it's safe and economically survivable for you to do so, I would have a direct and honest conversation with them about these things. Oh, he says, I also feel as though their shame and weirdness is inescapable. Is this common? How do I separate myself mentally from them, even though I physically need to live with them or work 40 hours to afford to move out? Yeah. I mean, if you're completely or largely economically dependent upon them, I think you might have to hold off on that conversation until you have more liberty. But certainly you trust your body. You can dislike people enormously and still be around them as long as you're conscious of it and don't fight it and try to really get to the root of it and understand it. I don't think taking a few placeholders with cool names is worth throwing out research funding. It's 95%. 95% is not a few. Oh, you sophist. This is what I mean. Like, scientists just can't be honest. All right. I feel like this is a semantic issue and not a claim on the existence and practicality of these placeholders. Okay, well, you don't even know what a feeling is, bro. That's not a feeling, that's a judgment. It's not a semantic issue. All right. At least churches generally don't get their funding through tax slavery. Well, that's a good point, my friend. A good point. Just getting to the every belief system gets one free miracle. In physics, it's the Big Bang. UPB doesn't need one. Of course, the great problem with modern science is moral nihilism, right? That you can't get the ought from the is. I would rather be raised religious and believe in morality than be raised scientifically and be a moral nihilist, which is the inevitable consequence of science without moral philosophy. We need morals more than we need flat screen TVs. Although people generally prefer flat screen TVs in the short run. The universe itself is most likely eternal in the same way that God is. So I have no issue if people want to place God on top of things, as it just shifts things up a degree. Okay, I don't really know what that means philosophically. It's just a bunch of words. What if all just always existed and goes through states of expansion like now, then loses expansion velocity as its size increases so that it contracts and falls in on itself right into a single point? Yeah, that's the big heartbeat theory of the universe. Not much evidence for that, unless if they can jack up the effects of dark energy to the point where it begins to collapse things back to the singularity, maybe, but then why would that change? Why would that change? Then you have an effect without a cause. Big Bang Theory is a psyop to make physicists look bad. Well, my concern is that intelligent people are drawn into the realm of physics when they should be actually working to make the universe and people within it a better place. What happened to Steph, bro, that he disappeared and has to start from scratch? Baby, I was watching all his content, then he vanished a few years ago. Well, what happened is you didn't follow me one website over, and so I disappeared to you. You don't think. You are just a product of thinking. Yeah. It's a Deepak Chopra comes little fortune cookie that comes at the end of your meal. The dark matter is a silicon within which our electrons are suspended as they experience the pathways programmed physically into the hardware that runs our simulated universe. Okay. All right. If you could edit the U.S. Constitution to prevent the U.S.'s current collapse, what would you add? I mean, life, liberty, and property was the original formulation. They had to change it from property to the pursuit of happiness because of slavery. You can't be property and own property. But none of that. I mean, the Constitution lasted at best 80 years before it was shredded in the Civil War. So you can't control political power. You can't control political power. And voting is just a way to get you to not rebel. All right. Intelligence is on a normal distribution, and we should do a little bit to move the average that is voting up a bit. You should get someone with a physics background to help explain all of this so you can make sense of it. So rather than tell me what I got wrong, there's just this vague intimation that I got things wrong and someone else could explain it better. See, if you can't explain what I got wrong, how do you know that I'm wrong? All right. God could very well sustain the universe, including us, through dark matter and dark energy as instruments or secondary causes. They would not be God, but they could be part of the created order. Again, just some words. Aren't galaxies flat planes due to the fact the singularities at their centers also have rotation? Same reason why Sol's planets orbit in a flat plane. Yeah, I mean, that's what I assumed that the dark matter was in the center, not in these angel wings on the outside. Maybe both. Maybe that's what's needed. Who knows? That's assuming dark matter operates within conventional known physics. But it is possible it operates under entirely different sets of principles, ones we cannot measure. But why? But why? All right. The physics world has an issue when it comes to explaining practicality to the layman. Well, sure, but that's because the physics world, because when you run things from government funding, the goal is to make things as complicated as possible. And when you run things to the general public, as I do, the goal is to make them as comprehensible and useful as possible. So it is just narcissistic and selfish to take government money because it separates you from the people who are paying for your daily bread. It's possible, even, says someone, that dark matter exists on a different order of reality, where things like mass and volume are not even a thing. Something like a universe that a wave is to us could be matter. I mean, you can make up anything you want. You can make up anything you want. That is a false equivalence. This is a placeholder in a system of equations. It is not actually 95% of physics. I didn't say it was 95% of physics. I said physics can't explain 95% of matter and energy. I didn't say it was 95% of physics. Regarding the vaccines, even the 95% effective was misleading because they based that on relative rate risk instead of absolute risk. Right. So if you go from 1%, let's say you go from 1% reduction of symptoms to 2% reduction of symptoms, you can say the efficacy is 100% higher because it's gone from 1% to 2%. And people say, wow, 100%, that sounds like it gets rid of all symptoms all the time, no matter what, when it's relative to 1% to 2%. Whereas if people say, if you take this experimental gene therapy, you get a 1% reduction in risk. That's not right. That's not a real thing. All right, so let's see here. Of course, we put money into abstract research that could become useful later. Think nuclear energy and quantum computing, also AI. Yeah, and then people should invest that. That's what investors are for. When I wanted to start a company to do environmental and health and safety stuff for business, I went to investors and they invested. I didn't run to taxpayers using the government weaponry. Dum. I get a vision of Shoe on Head sometimes when watching YouTube. She's very funny. She's very funny and very sharp. Europe is a narco-tyranny. Yeah. No daughter this time. Disappointing. Yes. I'm sorry. I'm sorry to disappoint you, but just me. Are you telling me the hockey stick graft isn't 100% truth? Shocked Pikachu face. Very true. I'm never going to get through these comments. They're coming in too fast. Grant money, not great. So you are doing research to create a product for the client that is the military that generates byproducts of knowledge. Whatever. Yeah. I mean, it should all be private. There should be no force in the transfer of resources. Of course. All right. I just asked Google, is Molyneux a science skeptic? Well, all science should be skeptics. It came back with something about William Molyneux, my ancestor, before calling Stefan a MAGA hat-wearing racist. Oh, please don't talk to Google. What are you, crazy? Talking to Google is like talking to a coke-snorting communist in a dress. You gotta be kidding, right? Yeah. All right. Let's see here. Uh-huh. All right. Let me just get down. I think we're good, and I think we are. I've lost track of where all of these are. Okay, well, I think I'll stop here. freedomain.com/donate. Help out the show. Really, really would appreciate it. Thank you so much, my friends. I appreciate your rant. Again, please feel free to call in, set me straight, and tell me all the things that I got wrong. Last thing I want to do is be wrong. I recognize, of course, this is a rank, amateur, non-scientist set of rants and opinions, so hopefully it makes some sense. If it doesn't, please let me know. I will set the record straight in public, as I'm very happy to do. And, somebody says, aside from all the science discussions, I'm curious on your take on polyamory. I know some people who are poly. There's just no way I can rationalize with how my mind works. Yeah, so polyamory is a child abuse results, usually early child abuse, sexual abuse, and so on in particular. And it also comes from seeing a rotation of usually men cycle through your mother's bedroom, so you don't get a sense of pair bonding and so on. And it is a way for people to get slightly more desirable sexual partners by offering to share them with others, or maybe any sexual partners and so on. And it should be, if it's private, it does not require the initiation of the use of force, so it's not evil to do, but it's severely dysfunctional and absolutely messes up children. So it definitely is wrong that way. All right. Thanks everyone so much. Have a beautiful evening, my friends. Lots of love from up here. I'll talk to you soon. Bye.